power. So power, basically, again, if we use the colors consistent. And all we've really got here is the idea of what power is. Basically, it's how quickly we use energy. But in the case of electricity, we're using energy through electric current flowing. So the two equations that we're going to have are power is equal to voltage times current. And if you put your units in there as well, power is measured in watts. If you're not sure about the symbol, write the full word out. Voltage is in volts and current is in amps. Okay, make sure you actually know the units. And if you're unsure about rearranging, what I would do is on your own one, put the rearranged equation in as well. That is quite useful. The next one, this is two equations. So this is the equation that links power, voltage, and current, but we've also got an equation that links power with resistance. So power is equal to I squared ohm. Okay, so basically all this really is knowing the equations. And again, know your units. Power is in watts, current is in amps, and resistance is in ohms, that being the symbol for ohm. If you can't remember the symbol, write the word out. Okay, this one, the thing to remember is the I is squared, so it'll be a good idea, so if you can do the rearrangement of this, which would be I is equal to the square root of P divided by R. Okay, remember rearranging. If it's multiplied on one side, it'll be divided by the other. So this is I squared multiplied by R. So the other side, the R would be divided. So it'll be P divided by R equals I squared. Here, if you wanted to find V, remember it's V multiplied by I. So V on its own would be multiply I would go on this side. It becomes divided. So when it goes across the equal, it's the opposite sign. Okay, and that's pretty much all you actually need for that. The next lesson is lesson 11 is on energy. And again, it is just two equations. So we can do that up there because we've got enough space up here. So energy transfer. Okay, and that one is again those two equations. So energy is equal to power multiplied by time. Make sure you know these equations. You must know these equations. Energy measured in joules, that is a capital J. Power again watts, and time is seconds. That's a lowercase s. Thing to note, you must write down capital J. You can do it as a big J, but just don't put the dot on it if you do it in lowercase. Okay, because if you do it in lowercase, you will not get the mark for it. However, if you do don't put the dot on it, it doesn't make any difference. And then we've got the equation which links energy, charge, and potential difference. E equals QV. Again, just make sure you know your units. Joules. Charge is measured in coulombs. That's a capital C. Lowercase c looks the same as a capital. Okay, so that doesn't work. And the voltage is V. So the only thing you really need to know then to go with those is in terms of power and work, which is this one. So work, what actually is work is done whenever this charge flows. All this is showing is that work's done. Work is energy being used. So whenever current flows, work is done. So work is done when charge flows. And that's basically what that is telling you. Work is done and the charge flows. And then this one, you can say that it links in with electrical devices on power, that when power increases, you write this in the words if you want, the energy use also increases. So if you've got a 2 kilowatt kettle compared to a 10 kilowatt kettle, well, let's do a shower. So say we got a 5 kilowatt shower against a 10 kilowatt power shower, that uses more energy. To get 10 kilowatts, you'll have more voltage and more current. Well, actually, you'll have the same voltage, 230 volts. You'll have more current will be drawn from your mains, which basically means you use more power. So basically, if the power increases, it uses energy faster. You can write that out in words or do something like that, where I've done it as symbols. Okay, and that is all you need for power and energy transfer. Basically, the 4 equations. Learn them, make sure you can rearrange them. Okay, and that's pretty much